Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of the conceptual knowledge in the field of civil engineering where study elaborates decoding the earth to build a better world. Today we will go through the core concepts of structural geological components like faults, folds and joints. Here we will discuss the structural geology components with special focus on the structural components like faults, folds, joints from the civil engineering perspective. Structural geology helps engineer to understand that how rocks have deformed or displaced under tectonic stresses over geological time. The major structural components with their discontinuities significantly influence that the behavior of rock masses during construction activities. For any type of projects like dams, tunnels, highways, bridges, and foundations, geological structures directly affect stability and safety. Therefore, engineers or engineering geologists or civil engineers must carefully study these geological features before construction begins. The faults, which are the structural components of the rocks which gives the impact on the layers or the orientation of the layers. So fault is a fracture or break in the rock strata where movement has occurred between two sides. Faults develop when tectonic stresses exceed the strength of rocks and cause displacement. So tectonic forces are impacting on the existing rocks and they may trigger, trigger or cracken the existing rocks into the fracture ones, that is deformed structures. The displaced zone becomes structurally weak and when contains crushed rock material known as fault gauge. With reference to civil engineering point of view, these fault zones are highly important because they reduce rock strength, increases seepage, and may trigger the seismic instability near engineering structures. So, with reference to structural geology, we have to analyze the rock arrangements to determine the physical process with reference to the natural phenomenon like temperature, pressure, and stresses that are produced in between them or in between these tectonic layers. So that tectonic forces are acting on neighbor tectonic plates or one plate to another tectonic plate. With reference to the civil engineering point of view, the earth is an state is not a static. It is a material that has yielded to force, means that absorbs the forces or stresses, but there will be a deformation or displacement within the rocky layers. The stress versus strain relationship is explained. This relationship is most important for the forces which are acting or the stress which is impacted by a tectonic layer to n number of tectonic layers which are available or present nearby it. The causes of the stress ellipsoid are that compression, that is a push, and tension, that is a pull. So with respect to the compressive force, that is a pushing force which shows the deformation of the pre-existing rock, or it may get flattened or it may get layered structure due to these compressive forces, but at the initial level it is a in circular shape. At the same time, with respect to the tension which is acting, the whole natural shape may get deformed and stretch with reference to that pulling action. So the effect of stress strain curve shows graphically here strain on the x-axis with reference to the stress on y-axis. So at the initial level up to the elastic limit, there is a stress is directly proportional to strain. After that elastic limit, which is recoverable portion, the whole curve which shows the plastic range, which is a permanent flow, or we can say that the folding nature or the exact change in their position or shape after some stress and strain rigorously acting on it. At some point there may be a rupture point at the third level. That rupture point is nothing but the end point, we can say that, where breaking or faulting may occur, means that whole rock does not sustain the excessive pressure or stress. So high pressure, or we can say that the temperature favors plasticity, that is the faults, and the low pressure or the low temperature favors rupture. Low pressure and temperature favors rupture, that is faults. Means the faults and faults are studied on the basis of stress strain activity or the curve. The ductile response due to the faults. Here the diagram itself explains that there will be an axial plane and the hinge and limbs on both sides, where the compressive stress are acting on that layered rocky surface from both sides in the inward direction. So the folds which show the ductile response, which is a flexure, or we can say that undulation in the rock strata, typically resulting from compressive stress acting on ductile material. Folds are bends or curved structure develop in the rock layers due to compressive tectonic forces. Unlike that brittle folding, which represents the ductile deformation or displacement of the rocky layer or rock masses, fold structure influence groundwater flow, slope orientation, and underground excavation behavior also. Therefore, fold interpretation is important for geological mapping and civil engineering site investigations. So, what are the classification of folds? Anticline, syncline, and overturn. Three types of folds or three classes of folds. First, anticline, where convex upward, that is force acting convexly upward and oldest rocks in the core. In syncline, convex downward force will be occurred where youngest rocks in the core. And overturn, where axial plane incline, both limbs deep in same direction. So anticlines, synclines, and overturns. So an anticline is an upward arc shaped fold where rock beds deep away from the fold axis. A syncline is a downward through shape fold where beds dip towards the fold axis. Fold geometry controls surface drainage, groundwater accumulation, and slope behavior. So civil engineers must use fold interpretation while designing the tunnels, reservoirs, and hill slope excavations. Engineering significance of folds, or we can say that the use or applications of fold or the importance of folds with reference to civil engineering point of view. The rocky layers or the structures which are most important for the tunnel point of view, tunnel construction point of view, where that existing or pre-existing rock layers or their patterns or their orientations must have to study by the engineers before starting the actual construction activity. So tunnels in anticlines and tunnels in synclines. As anticlines and synclines are the classification of folds. So with reference to that anticlines and syncline nature, generally in anticlines the rocks are stable. So tension releases fracture stresses, and also the percolated water will be drained out. In tunnels in the syncline folds, where high compressive stresses are occurred and which traps high pressure water also. Means the diagram first, anticline tunneling where tension or arc section will occur which gives the stability to the tunnel where forces are acting away to the tunnel. In second, syncline tunneling, the whole pressure or whole forces are acting towards tunnel which are acting compression. Due to that, rock burst risk will be in future. So what is the importance of slope here in anticline tunneling or syncline tunneling? Cutting parallel to dipping limbs invites landslides, the rupture, and the displacement, or we can say that the deformation due to the external forces is the surface along which the rock displacement occurs. Fault is a fracture or break in a rock strata where movement has occurred between two sides. Faults develop when tectonic stresses exceed the strength of rocks and cause deformation or displacement into the natural one. The displaced zone becomes structurally weak and often contains crushed rock material known as fault gauge. With reference to civil engineering, the fault gauge are highly important because they reduce rock strength, increases seepage, and may trigger seismic instability near engineering structures. The block above the fault plane it's called as the hanging wall, while the block below to that is known as the footwall. A fracture rock which visible displacement has occurred parallelly to the surface, which shown with reference to the orange color, where a crack with no movement is a joint, a crack with movement is a fault. A simple differentiation in between fault and joint is that a crack with no movement is a joint, and the crack with movement or deformation or displacement is a fault. So mechanism is that brittle deformation, that is low temperature or low pressure or rapid stresses which are impacting on it. So what is the anatomy of a fold? First is the hanging wall, second one will be the foot wall. So hanging wall, the block above the fault plane, and the foot wall, the block below to that fault plane. So both hanging wall and foot wall are explained in the diagram. The hanging wall is where the miner hangs their latten. The foot wall is where they place their feet. What is meant by the classification of faults? So three faults: normal fault, reverse fault, strike slip fault. Normal fault is occurred due to the tension, reverse fault occurred due to the compression, strike slip fault due to the shear. So normal fault diagram, where hanging wall is in upward direction, slip foot wall will be in downward direction, and both walls are stretching in opposite direction or away from the each other. In reverse fault, there will be a compression, so the forces are acting in inwards, where hanging wall may get in upward movement and the foot wall is in the transverse direction. That is a reverse fault. In the strike slip fault, both type of walls are at the same phase, but they are moving away from each other, but with reference to some shear. That is strike slip fault. So the normal faults develop under tensile trace conditions where earth's crust undergoes extension. This normal type of fault is the hanging wall blocks moves downward relative to the footwall. These faults are commonly associated with rift valleys and extensional geological environments, whereas reverse faults occur under compressive stress conditions where rock layers are pushed together. In reverse fault, the hanging wall moves upward relative to the footwall. The fault plane has a very low angle. It is called as a thrust fault. The strike slip fault, where displacement occurs mainly in the horizontal direction parallel to the strike of the fault plane. These faults form under shear stress condition. Depending on movement direction, faults may be classified as right lateral or left lateral. Strike slip faults are particularly dangerous for highways, pipelines, tunnels, and bridges because horizontal displacement must damage structural alignments. We have to check the field, or we have to check the recognition for any type of civil engineering projects based on the available rocky surface or the embankment. We have to check some samples, we have to check some tectonic plates, we have to check some slopes or gradient, or we have to check some rock on its fragments. Likewise, we can check the field recognition for the sake of our interest where we are doing the activity of existing construction or proposed construction, which is a repetition of strata where reverse fault is there. Repetition of strata means a single rock layer comes alternatively or significantly. In second layer, there will be a slicken sites where the friction marks are there. With reference to that friction marks, we can check that the importance or the impact of friction on the rock, or we can say that the strength of that rock may check by using that friction mark. In the third one, where will the drag faults is there, where the arrow marks are shown the acting compressive forces from both vertically in all direction, horizontally in all direction. And at the fourth diagram, there are the rock fragments are there. With reference to that rock fragments, or we can say that the breccia fragments, we can check the fault breccia or its type. So these recognized field will be most important for the detective work or the safe work for the future project development. Joints are the cracks or fractures present in the rocks where no significant displacement has occurred, or we can say that divisional planes or fractures with no visible displacement. They, the joints are commonly developed due to tensile stress, cooling action, weathering action, or unloading processes. Joint system divide rock masses into separate blocks and significantly influencing engineering behavior. They may increase permeability and create potential failure surfaces in slopes and excavations. So, what is the significance of the joints? The most common structural feature in the crust, rarely isolated, they occur in systematic sets. That joints are most important also and most dangerous also with reference to the water percolating through it, or it may give the support to other type of rocky layers. Tectonic joints, sheet joints. So image 1, which shows the tension joints open and rough, and shear joints, they are tight and smooth. So two types of tectonic joints, shear joints and tension joints. So shear joints are in the orange color and tension joints are in the blue color. Likewise, we can bifurcate it for the study point of view. Where sheet joints, they are exploitations or exploitation, which shows that the unloading or we can say that the relief of pressure in the pre-existing rocks or in the deposition of rocky layers. Means that joints are supportive or they may increase the life of that existing tectonic plate. So bedding joints occur parallel to bed planes in sedimentary rocks. Strike joints develop parallel to strike direction, while deep joints occur parallel to the dip direction. Rock mass behavior. So we have to study the mass of the rock. So engineer builds on the mass, not the specimen. So we are constructors or we are creators. We have to create a huge structures just like dam. So we can't prepare any specimen. We prepare a structure. So the strength of that structure or mass is determined by its defects or by its discontinuities. So here a, a figure first, there will be a rock block which is equi-space or equi-size and which is intact rock with high strength. There will not be any crack or there will not be any joint or there will not be any tectonic layer pattern or orientation. But in the same second image, there will be a rock mass which is with reference to equi-space or we can say that the cracks or the folds in between them. So which reduces its compressive strength. Here, if the forces are acting on both type of cubes, then that first rock may sustain that whole forces. It may be compressive force or tensile force. But the second type of rock change their original position as it is already in cracky nature and it may get broken into fragments. The infrastructure at risk. So here we are studying the structural components, that is folds, faults and joints. So with reference to these three parts, three images are there. First image shows that the leakage and uplift. Second image shows that the wedge failure. Third one will show the planar sliding. What is what is the impact of uplift force on the dam wall, as the dam will be constructed on the cracky rocky layer. It may deform due to the internal seepage and it may get overturned. Wherein second, the wedge failure will be there with reference to that cracky rock, and if we consider that type of rock for the tunneling, then there will be a wedge failure and that whole tunnel may get collapse. In third, planar sliding, where the n number of rocky layers are available within the hill and we are planning to construct a roadway by the cutting and filling technique on the contours. So with reference to that planar sliding, one of the tectonic plates may get slide in horizontal direction due to some compressive force or the planar sliding activity, and that whole rock surface may get slide down just like the landslides on the roadway. So here the infrastructure at risk is most important to study as a civil engineer point of view, to prevent the disasters, to save our structures and the beneficiaries on dependent on it. So remedies are grouting, rock bolting and slope orientation. Means if we have to prevent this type of landslides or disasters, then we have to follow that methodologies of grouting within the rocky layers where sealing the joints. Means we have to pour the any grouting material by using the jetting technique into that cracks, and we have to seal that cracks. That means we have to improve the strength of that rocks. Second one will be the rock bolting. Means we have to drill out the whole rocky layer or the fragments, and we have to bolt it by using the stitches, so that the whole cracken rock may get hardened with reference to that procedure of rock bolting. And third one will be the slope orientation. Means we have to study the pattern of slope which is in the tectonic plates naturally. Then we have to decide the cutting and filling position or the way of cut and fill where there will not be any planar sliding. So slope orientation, which will be the most important point for the same to prevent the disaster. Summary and exam blueprint point of view, structural geological components are the comparative analytical part where we can compare the fold, fault, joint on the basis of its behavior, on the basis of its action of the forces acting on it, or we can say that the deformation which will be held after the forces acting on it. So the graphical representation or the tabulated format explains the behavior of fold, which shows the ductile or bend nature. At the same time, the action will be the plastic, and result there will be a deformation in the rock. At the second, fault, its behavior must be brittle or break the existing rock. It may create the cracks in between them, and at the same time there will be a displacement, and the existing rocks may change their original position. Third one will be the joint, that also gives the brittle or break, or we can say that the change in their change in their original structure to the fragments where no displacement is there, but there may be a cracky layer. So with reference to exam point of view, we have to start to mark the answer the questions. So we have to go for definition of each and every technical structural component, which gives you the introductory marks. Then we have to classify the faults, classify the joints with reference to its diagram, with reference to its forces acting on it. So here we have to illustrate, or we have to explain the diagram part with reference to the forces acting on it, with reference to the structure, with reference to the displacement, and with reference to the change in their natural phenomenon. And at the last we have to signify your answer with reference to the risk point of view or the engineering consequences point of view, where we can use some shotcreting method, grounding method for minimizing that techniques. So the faults, folds and joints significantly influence the strength and behavior of geological formations. These structures affect excavation, safety, foundation stability and groundwater movement. Detailed geological investigations help engineer to identify risk and design suitable mitigation measures. Structural geology forms an essential part of planning, designing, and constructing safe and sustainable engineering projects. Stay tuned, guys. Happy learning.